So I'm going to tell you about using SQL FHIR in the IG publisher and where it's a cascade of things. So let's start by talking about why I'm doing this. So a FHIR implementation guide. Some of you will have run into implementation guides. They're kind of everywhere. It's an implementation guide is a publication that tells you about how to use FHIR to solve a particular problem. It contains human-readable narrative that describes how to use FHIR, and that's HTML that you use in the browser, and also has a kind of set of computer readable resources that allow for tools to create and create code or validate instances or put up an API or whatever. And there's a package that contains all those things for the tools. Now, and it builds these things by writing all the resources by hand with some kind of tooling assistance or something. Then the resources contain all the computable rules that everybody's going to make use of for code generation or validation or whatever. And then they author the narrative for humans to read. They author fragments of that as Markdown or as XHTML. Most use Markdown. And then they're just going to sit in a cycle, editing those, getting input from implementers and stakeholders and policymakers and whatever as they figure out how a set of community is going to implement and solve a particular problem. So they two kinds of inputs: resources, FHIR resources, and human readable markdown or narrative. And then we provide, which I author, the IG publisher. So it's a Java command line tool that basically takes all the inputs in the form of resources and validates them as deeply as we know how for quality and consistency for implementers. Then the publisher generates a massive series of XHTML fragments, all different kind of views of those resources, and there's 100,000 plus of those. And then it uses Jekyll, which is a website builder, to stitch all of the fragments and the human supplied narrative together using a template that controls all of the assembly. Then it checks the HTML for broken links, and which are astonishingly easy to create. And finally, it builds the output package that the tools are going to use. And so the IG publisher runs constantly and it builds all those things. So it turned out to be a really big ecosystem. A group of us sat down and scoped out what the IG publisher would do, and we thought maybe there'd be 70 or 80 implementation guides ever. That we had no idea. I've personally seen over 800 across all the different ecosystems that I support with IG Publisher, and it's been used in some, to me, very surprising ways for general purpose documentation publishing, where you're dealing with some content represented somehow in FHIR resources. And I want to acknowledge that we've had considerable investment in the ecosystem from the US government to create and make it possible. Now, there's a challenge, and the challenge is that there's pretty limited ways to build ad hoc narrative from resources. So we generate all the representations of resources, and you can drop one of those into your human readable narrative and say, hey, when we're talking about the narrative, we're talking about the resources, but there's only a limited number of XHTML fragments that we generate, 40 or 50 types of narrative for each kind of resource. And authors often want to mix and match and make up their own narrative, but quote from bits of resources or create summary tables that navigate across multiple resources to help the reader find what they're looking for. Now, I'm going to talk about the second part today and how I used SQL on FHIR to solve that problem. So let's take an example to show you what we mean. We'll take the example of the vital signs implementation guide. Just a real implementation guide. Went to ballot, published by HL7, and it talks about the details of how to consistently represent vital signs with information about how the observations that led to the vital signs were observed, with the patient, for instance, the blood pressure. What was the posture of the patient? Makes a clinical difference. How would you consistently represent their posture, for instance? So that's the vital signs implementation guide. And it has in it a table which summarizes the various profiles. So I said, let's imagine that I'm going to supplement this table with a table of all the examples that are in the implementation guide, because we encourage implementation guides to have examples to help people see what the profiles mean. So I want to add table of examples, and I could build that by hand, and just every time I author an example, I'll add an entry to the table and I'll fill out the HTML to get the codes and the things I want in the table correct. But it's extremely tedious to do that. We value author's time. It's also really easy to make mistakes and to find that the table doesn't line up with the resources because you fixed a resource, then forgot to fix a table. Anytime you have dual authoring like that, problematic. So really we want to build it automatically. So let's go ahead. And so it's very much the SQL on FHIR use case. We've got resource and we're going to flatten it out to a table and then drop the table into the narrative. It's very much what we're going to do. So first of all, there's actually SQL inside the IGs. So one of the outputs from the implementation guide publisher is a database, a package.db, which is an SQLite database containing a summary of the content in the implementation guide. There's a couple of links, and these slides will come out and you can look at the links. You'll note that the links aren't to the HL7 website. It's actually a bunch of those files on the website, but the website won't serve them up. So I've got to sort that out. I discovered that while I was making these slides up. So I got to talk to the webmaster about getting the DB files served by the web server. And that's why the references are to other web servers. But they all implementation guides in the last few years have package.db. So quickly, just using the SQLite browser, let's got a list in here of code systems, value sets, resources, information about the implementation guide. And if you're not interested in looking inside the resources, you really want to find some very specific thing quickly, you could do it this way. It's pretty widely supported SQLite, and here is a table inside the list of resources that are inside the implementation guides, code systems, device examples, and information about where it's found in the website. Some of the old ones you'll see have a mistake. I just found that last week actually and fixed that up. So there's provided as a service to the implementers, although not many people have made use of it yet. But there you go, I have SQL infrastructure. So let's leverage that. We're going to use view definition. We're going to register it with the IG publisher so it knows about it. We're going to fill out a view definition that builds a table, and we're going to build the table and put it in that package database. Then we're going to build and the view definition. And finally, we're going to assert the content into the pages using some SQL. So we'll just work through those steps. And if you're not an author of an IG, you don't care about this particular bit, but you have to register the view definition. So there's a config file where you say, okay, I've got a view definition and it's this view definition. That's pretty straightforward. There's other ways to do that depending how you author the implementation guide. It's not important for this presentation. And we fill out the view definition. Here's my view definition. For every observation, I'm going to create a table with a column for the internal resource key, which we'll come back to, the ID, meta.profile, code and units and body site, and component codes and units. Now, this is super simple view definition because it's not my purpose to dive into the full complexity of view definition here, but I will say everything that a view definition can do is fully supported. So I could get as complicated as I wanted here. That wasn't my focus here. And so, great, I wrote that. Then I built the IG, and in the QA part of the IG, with the editors check to see what they got right, get a bunch of these warnings. The column is not defined as a collection because you'll see I didn't say that they were collections. I just said, here's a name and a path. But actually, the path statement, code.coding.code, might return multiple values. So what the heck happened there? I don't know what that was wrong with that slide. Here's my code.coding.value. Code in observation is a codable concept. Codable concept has multiple codings which have a code. So code.coding.code could return multiple values for code. And in fact, I don't want that. Now, I happen to know, since I'm authoring the implementation guide, that there are not multiple codes in any single observation. Every one of them has a code with a single coding, and so that will be a single value. So I can look at this and say, it might, but it's not actually going to, and I could ignore that. Alternatively, I could go, actually, that's a point. Maybe at some stage in the future, I will add a second code. It's not a stupid thing to do. So let's get that right. So instead I say, let's fix it up. So code.coding and say only the first coding will take the code from. I went through and did all those things. And it's probably good practice to deal with those hints and warnings. But what I wanted to point out is, I don't know what's going on. This slide says, I wanted to talk about the code. And since this slide, I don't know entirely what's wrong with the code. So what are you doing to me? So why did it do that? Well, that didn't help. I will sort this slide out, and what I wanted to show you is that this code, all the code that runs this I'm showing you is all in the FHIR core. There is all the code. And so basically there's a validator and there's two implementations of storage. And those are all available. The point of this slide is to tell you that those are all available in the open source FHIR Happy Core. So if you use Java, this is all fully available. So the runner reads a set of resources, which it takes as input, and pushes data into the storages. I don't know why runner's there. So this is a push-based model rather than a pull-based model like some of the others. It can check the view definition against the FHIR schema, which I just showed you it doing, and it can store in either SQLite or JSON. So all that code is there for everybody to use. It's fully configured with the view definition test cases and spec so far as I could tell, and every feature of FHIR is supported. Okay, but in my choice, the SQLite storage doesn't allow multiple values per column. Just make everything simple for what I'm about to show you. So then we rerun that, now that we fixed the view definition up, and we get an output in the package.db file with a row key, which I always add in the storage, a resource key, which is a internal reference to the resources table, and then the ID, the profile, the code, the display as laid out by the view definition. There's no display in the table. And also, to make it useful maybe for people, we also generate a JSON file that contains the rows with the same data as in the DB file, but in JSON. So if that's good for you, then you could make use of the JSON. And so both of those will be in the published implementation guide as defined by that view definition. Oh, lovely. Really, I don't know what PowerPoint's up to here. Why are you... Oh, I know what I want to do. Okay, here we go. Then I simply drop the narrative into the narrative that I'm authoring in a page that I author as a human. I simply drop this statement. So this is the liquid include tag, and I'm going to drop SQL in, and I'm going to select all the columns from that, and the name there is the name that I gave it in the view definition. And here's the table it produces in the resource, the ID of the resource, the code, the display. We could do better than this. If we could tell the generator that generates the HTML what to do with these columns. It's just presenting them as strings, although it's clever enough to automatically recognize and link to the URL. But we can do better. So instead, we're going to do a little JSON that says, this is the HTML class to use. And here's the columns to build with their human-readable title, which is not the same necessarily as the SQL field name, and how to build the column and the source fields. So for instance, the third column is code, and it's coding, and I'm going to tell you the system, or it could be a field name in the query instead, and the code and where the display is from. So we'll go through and fill out those details. Now, when it renders the code, it's much cleverer. It automatically links to the resource and digs up the text for the resource. It fills out, still does the profile the same. But see, with the coding now, it's actually used the underlying standard reference rendering for coding, and it can go off and look up in the background the display for the code and link to the link definition, a bunch of useful stuff. And so then we would just have this table in the output, and that's how we use SQL on FHIR. If you want to look at this, I did a PR against this implementation guide. It's draft PR because the author didn't actually necessarily want, and probably doesn't want, the summary table in the implementation guide that documents how to do all this stuff. And you can tweet me. Is it still called tweet? I don't know. X me or whatever. And I'm all over chat.fhir.org.
Thank you, Grahame. I think guys a little bit tired. So how long it took to implement it? What is your experience as implementer of SQL on FHIR? Was it some
Kind of tricky to answer that because I have a full-blown FHIR path implementation that's got all the features that took, honestly, hundreds of hours to chase down all the loose corners and terminology parts and the whatevers. But it's, it's a core feature of the underlying implementation framework. So I started by saying I already got that, and I've invested deeply in that for many years. And then I wrote a view definition parser and the validator, maybe a few days. And I wanted to get the validation, in particular, the warnings around cardinality. So that's a few days to write that. And then the SQL, to actually run the view definition, having done that and passed the tests over a few days. The actual SQL bit, I rewrote it completely while I was doing this presentation. It took 2 hours. I mean, it's a bit of a how long is a piece of string. But in terms of like, how else could I have done this? Really? I mean, I could write a custom query language. All of those options would be way more expensive than doing it this way. And the beauty of the view definition approach is once I've done the view definition fundamentals, then there's all sorts of different ways to reuse it really easily. And I'm sure that people out there will find my view definition engine that's, deployed basically because the FHIR core is part of Android, the Android SDK, they're happy. It's pretty widely deployed. I'm sure people will find all sorts of use for it. John's got a question. Go, John. You're still awake there, John.
Yes, I'm here. Why not use collection equals false instead of indexer expression 0? Wouldn't you want to know if your assumption had been broken?
I mean, I could specifically have said collection equals false, wouldn't have changed the behavior, but I didn't need to, so I didn't. You still get the warning. And if you tried to execute in my implementation, if you don't specify collection, then it asks for storage. Do you do collections? The JSON storage does, the SQLite storage doesn't. And that was a somewhat arbitrary choice on my part that it doesn't. And so if you didn't say whether it's a collection or not, then they'll just say, well, it's a collection. I checked that it is, and I will tell the storage, do you do collections or not? If the storage says yes, then it's a collection. It would probably be good, given that you're going to not have collections, to be explicit about that. But actually, it's not going to change the behavior because you're going to have collections in the IG publisher. It's up to the storage to define that in my framework. So I would always recommend that authors be specific about what they think is going on with collections on the columns, but you're still going to get the warning. No, actually, if you say, no, it'll still be a warning. It'll say you said it's not a collection, but we looked at your content and it might be. So maybe you should check that. But sometimes you can be really sure that it won't be, right? And so you don't worry about that. But it's something we've seen in other contexts where people are using FHIR. It's really easy to accidentally end up with a collection and get unexpected outcomes in your implementation. And that's why those of us who work deeply on the FHIR engines are working on those kind of warnings to warn people that you look like you accidentally have a collection. Are you sure that you're not going to have a collection accidentally?